Okay, I'm starting this video. I didn't actually mark the last question, so we'll finish with by marking question 20. For this one, you picked up a processing mark if for showing your upper and lower bounds. So P1, it is then an A1 for the process to find the upper and lower bounds of times in hours. So I'm just trying to figure out where that fits. So in theory, that fits partway through here. So I showed it on that one. I was struggling with getting my calculator to show me the answer in the form that I wanted. P1 is given for the process to find the actual speeds. So it's for the process to find the actual speeds. And then 1, 2, 3. I'm just checking my marks. Actually, that was an A mark, not a P mark. And then a P1 mark for the two correct values, so P1 there. And then we are going for an A1 mark for 20 kilometers per hour, correct two significant figures. So that's my A1 there. Okay, question 21 then. So the graph of y is equal to f of x is shown on the grid below. On the grid, sketch the graph of f of minus x. So that's going to create a reflection in the y-axis. So that's going to, if I look at major points, so reflected in the y-axis, that would go to there, that would go to there, that point would go to there, that point there would go to 3 away, and then my final point would be there. And that's pretty much it. And then join that with as smooth a curve as I can. I'm trying to make it look as close to the other one as I can. That will do. Yep. Okay. Here is a sketch of the graph of y is equal to tan x. The graph of y is equal to tan x is translated to give the graph of y is equal to g of x. Following the translation, the point Q shown on the graph above moves to the point R, which has coordinates of 90 minus 5. Find an expression for g of x in terms of x. So if we think about that point there, and that's going to move to 90 minus 5. Okay. So first of all, the minus 5 is created. The minus 5 is g of x minus 5. So g of x, the minus 5 alone is going to create f of x minus 5. And then the 90 needs a little bit more consideration. So what we've actually done is we've moved from this point here, which would be at 180, 360. So that currently is at 360, 0. And we've moved to 90. So we've actually done minus 270, which would have the effect of being a f of x plus 270. So when we combine those together, f of x is actually tan x. So it is going to be, find an expression, so no equal sign. So it's going to be the tan of x plus 270. That's what will affect the x coefficient, and then we need to minus 5 from that, which would be the minus 5. Okay, let's look at the mark scheme then. Right, where are we? Okay, so we've got two parts. So the first part, B1, this mark is given for an appropriate sketch, and they've got the same as me, so B1 there. I should really have done that in a different colour, just for consistency. We'll go green, B1 there, B1 there. Right, and then for part B, for example, this mark is given for a method to describe one part of the translation. For example, 360 minus 90, or x plus 270, or x plus or tan of x plus a minus 5, and then A1 for the correct answer. So we can kind of pick up that anywhere really. Let's give it there. So M1, A1. Okay, and question 22, which is the last question on the paper. So the front elevation of the plan of a solid are shown below on the grid. Draw the side elevation of the solid from the direction of the arrow. So we're viewing this from this angle here. So the front face is 3 squares wide, so it would be, are we given a specific space? So I normally like to draw it, so I would normally draw it here, in this space here, but obviously because of the arrow in the way, it's kind of implying not to draw it there. So we've got 2, 4, 5 deep, 2, 4, 5. So we've got a rectangle there in effect, and then we've got this. This would create a line at this point here, so 2 down. We'd also have this front edge shown here, which would be 1 square up. And then in theory, we'd have this hidden edge, which we can put in as a dashed line. That's technically the most correct. It implies a hidden line. Very rarely do you actually need the dashed line there. Right, let's have a look. B2, this mark is given for a fully correct elevation, 5 squares high and 3 squares wide. So we'll go B2. And that brings us to the end of that paper. So sorry that this has been spread over, I think it's 4 videos in the end. My time commitments have been a bit shaky. I've been trying to fit this in between teaching lessons. So apologies for that, but hopefully you found it useful. Final thing I will do though is bring up at the end of the mark scheme, because this is quite useful. So all of those 22 questions linked to a skill. So however you're doing your specific revision, if for example you found question 12 and you want more practice on that topic, that was growth and decay / compound interest. So each of those will give you a hint as to targeted revision on the skills tested by each question, which can be quite useful. There is a copy of the mark scheme attached to the Google Drive of this video or in the Teams area. Suggested grade boundaries, I'm not particularly confident of these suggested grade boundaries, but they're a good indicator. No, I'm not particularly confident, but they're a good indicator. That's a bit of a contradictory statement. They're a good suggestion. I don't think that they've got particularly a huge amount of weight behind them though, but it's a good indicator. Right, hopefully you found that useful. Thank you for your time. I know we're getting close to the 2023 exam series. Good luck with your revision. Feel free to add a comment or question into the chat or the comment feature, and I will try and get back to you as soon as possible. So thanks again and goodbye.